KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.com.
In continuation to the last problem, in this class we start with exercise 5. Okay, so it is like 8th chapter, no? So according to the NCERT textbook, this chapter is 8th chapter. So it is exercise 8.5 or 5th problem. Okay, right, see here ma. A radio can tune into any station in the 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? What is the corresponding wavelength band? Right. So finally, they have given frequency band of tuning. Frequency band of tuning of a radio, that is 7.5 megahertz to 12 megahertz. Asking corresponding wavelength band. Okay, see here. A radio can tune to minimum frequency, that is what nu 1 is equal to 7.5 megahertz, that is equal to 7.5 into 10 power 6 hertz. And when you compare these two, this I can call it as minimum frequency, just I am comparing these two, don't go for any other. So when compared to this is what maximum frequency, right? That is the reason he put minimum frequency, no other reason. Nu 1 is equal to 7.5 megahertz, that is equal to 7.5 into 10 power 6 hertz. Next, maximum frequency, nu 2 is equal to 12 megahertz, that is equal to 12 into 10 power 6 hertz. Corresponding wavelength for nu 1 can be calculated as, right, can be calculated. Lambda 1 is equal to C by nu 1. This formula C is equal to nu lambda. So lambda 1 is equal to C by nu 1, that is equal to 3 into 10 power 8 divided by 7.5 into 10 power 6. It is 7.5 7.5 into 10 power 6 is equal to 40 meters, right? Why? Because it is 75 into 10 power 5, okay, and it is 25 will come in the denominator, and it goes there means it is 100, okay, and it is what it is 75 by 10 means it is 75 into 10 power 5 will come. So when this 10 power 5 will go to the numerator, it is 10 power 3. So 10 power 3 means 1000, no? 1000 into 3 divided by 75. So 3 1 ja 325. So there is 1000, here is 25. Means what is the answer? It is 40, no? 25, 40. So here corresponding wavelength for nu 1 is 40 meters. 40 meters. Next, corresponding wavelength for nu 2. Corresponding wavelength for nu 2 can be calculated as lambda 2 is equal to C by nu 2, that is equal to 3 into 10 power 8 divided by 12 into 10 power 6. So here 3 1 and 3 4 and here it is 100 will come, no? 100 will come, no? Right? See this. So in the numerator it will be 100. So 100 by 4 means it will give us 25 meters. 25 meters. So here corresponding wavelength for nu 2 can be calculated as lambda 2 is equal to 25 meters. Next, thus the wavelength band of the radio is, thus the wavelength band of the radio is 40 meters to 25 meters, 40 meters to 25 meters. That is the wavelength band of the radio, 20 meters to 25 meters. Next, that is what next problem, problem number 6. Problem number 6. See here. A charged particle oscillates about its mean equilibrium position. A charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power of 9 Hz. 10 to the power of 9 Hz. So, what is the frequency of electromagnetic waves? What is the frequency of electromagnetic waves produced by the oscillator? Produced by the oscillator. Okay, right. So, what they have given ma? What he is saying? A charged particle oscillates. A charged particle oscillates. A charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power of 9 Hz. With a frequency of 10 to the power of 9 Hz. Full stop. What is the frequency of the electromagnetic waves produced by the oscillator? Produced by the oscillator. Okay, right. You know very well the concept of that is what, how the frequency of electromagnetic waves, right? So obviously, you know, the source of electromagnetic wave is the oscillating charged particle, right? So from the concept of that particular, you can say that the frequency of electromagnetic waves produced is equal to frequency of oscillation of a charged particle. Am I right? Frequency of electromagnetic wave is equal to frequency of oscillation of charged particle. That is what next automatically that is equal to the frequency of electromagnetic wave produced by the oscillator is the same as that of a charged particle oscillating about its mean position. That is 10 to the power of 9 Hz. That is 10 to the power of 9 Hz. Next problem, that is what problem number 7. See here. The amplitude of the magnetic field, the amplitude of the magnetic field part of a harmonic electromagnetic wave. See why he is calling, why he is saying that amplitude of the magnetic field part? You know very well, electromagnetic wave consisting of oscillating electric field and oscillating magnetic field perpendicular to each other and also perpendicular to the direction of propagation of the wave. This is what the definition of electromagnetic wave. So electromagnetic wave is nothing but, you know, the contribution 50% from electric field and 50% from magnetic field. So 50% means you don't take this 50% for every physical quantity. So generally orally I am saying, right? Why I am saying 50% is just half of that, because electromagnetic wave is consisting of oscillating electric field and oscillating magnetic field. Oscillating electric field and oscillating magnetic field, right? You just take it as definition and just take it as visualization. Don't go for detail here itself. That's why I will repeat once again before going to enter into the 7th problem. That is what the definition of electromagnetic wave. Electromagnetic wave is nothing but consisting of one oscillating electric field and oscillating magnetic field which are oscillating perpendicular to each other and also perpendicular to the direction of propagation of wave. That's why here, as simple as such, he is calling the amplitude of the magnetic field part of a harmonic electromagnetic wave in vacuum is B naught is equal to 510 nanotesla. So nano means 10 power minus 9 no. So you can write it as given B naught is equal to 510 nanotesla. 510 into 10 to the power of minus 9 Tesla. Full stop. What is the amplitude of the electric field part of the wave? Right. Very good. So by giving the amplitude of the magnetic field part, he is asking what is the what is the amplitude of the what is the amplitude of the electric field part of the wave? By giving by giving amplitude of the magnetic field part of a harmonic electromagnetic wave in vacuum, he is asking the amplitude of the electric field part of the wave. Right. That relation, you know, that is what E is equal to C into B naught. Okay, first you see that given value, given data, B naught is equal to 510 into 10 to the power of minus 9 Tesla. Amplitude of electric field of an electromagnetic wave is given by the relation E is equal to C into B naught. That is equal to, C value is 3 into 10 power 8, no? Right. 3 into 10 power 8 into B naught value is 510 into 10 power minus 9. So, adikapram E value we are getting 153 Newton per Coulomb. 153 Newton per Coulomb is the E value. Next, therefore, the electric field part of the wave, therefore, the electric field part of the wave is 153 Newton per Coulomb. The electric field part of the wave is 153 Newton per Coulomb. 153 Newton per Coulomb. Okay, that is what electric field part of the wave. So in this question, that is what problem. In this problem number 7, by giving the amplitude of the magnetic field part of a harmonic electromagnetic wave in vacuum, he is asking to calculate, he is asking to find the amplitude of the electric field part of the wave. So given B naught as 510 into 10 to the power of minus 9 Tesla, asking what is the amplitude of the electric field of electromagnetic wave. This relation we know, we substituted the values of C and B naught. There we are getting E value as 153 Newton per Coulomb. So that we are writing the electric field part of the wave is 153 Newton per Coulomb. 153 Newton per Coulomb. Okay, right. Next continuation problem, that is problem number 8. See here. Suppose that the electric field amplitude of an electromagnetic wave. Suppose that the electric field amplitude of an electromagnetic wave is E naught is equal to 120 Newton per Coulomb, and that its frequency is nu is equal to 50 megahertz. There are two things. A is determine B naught, that is amplitude of magnetic field part of a harmonic electromagnetic wave, right? As simple as such, amplitude of the magnetic field part. Next, omega is the angular frequency. Next, K, propagation constant, and lambda, wavelength. So he is asking to find 4 quantities: B naught, omega, K, and lambda, right? So that is what amplitude of magnetic field part, angular frequency, propagation constant, and wavelength. Next, B, find expressions for B and E. Find expressions for B and E. Okay, right. So what they have given for this? They have given that the amplitude of electric field, so the electric field amplitude of an electromagnetic wave is E naught is equal to 120 Newton per Coulomb. That is what they have given, and the frequency also given as 50 megahertz. 50 megahertz. There are two things to find. One is A, another one is B. Right. I already told you what we have to do in A and what we have to do in B. Now, answer. See here. So first we have to write the given data. No. So given E naught is equal to 120 Newton per Coulomb. Frequency directly I am writing because it is 50 megahertz. No. So mega means 10 power 6. No. Right. In place of mega I am writing 50 into 10 power 6 into hertz. Right. 10 power 6 hertz. 50 into 10 power 6 hertz. Hertz means cycles per second. No. Right. Now I am going for A. First A and then I will come for B. A. See here. Determine B naught, omega, K and lambda. Right. First B naught. Magnitude of the magnetic field strength is given. Magnitude of magnetic field strength is given B naught is equal to E naught by C. Okay, right. So what is E naught? Is a given value 120. C value தெரியுமோ அது வந்து 3 into 10 power 8. 3 into 10 power 8. That is equal to, see here, it is 10 power 8, no? இது மேல இங்க இது வந்து 120, right? So 120 means it is 10, no? So 10 power 7 will come here. If you cancel these two things, it is 10 and it is 10 power 7. So 3 1 ja 3 4. So 4 into 10 power minus 7 will come here. 4 into 10 power minus 7 will come. So 4 into 10 power minus 7 means you can write it as 400 into 10 power minus 9, no? So 10 power minus 9 you can replace with nano. So here the answer will be B naught is equal to 400 nano Tesla. B naught is equal to 400 nano Tesla. Next, omega is equal to 2 pi nu. 2 pi into nu value is 50 into 10 power 6 as I already told you, and here also I have written clearly 50 into 10 power 6, that is equal to 100 pi into 10 power 6. Pi is 3.14, so it is 100 more like 10 square, it is 10 power 6. So 10 square into 10 power 6 means 10 power 8, no? So 3.14 into 10 power 8 radians per second. That is what angular frequency. Next, propagation constant K is equal to omega by C. Omega by C. Okay, right. Omega is just now we calculated, no? 3.14 into 10 power 8 divided by C value is the constant value 3 into 10 power 8. And here we are getting 1.05 radians per meter, because it is radians, no? It is what? Per meter. So it is what like meter per second, it is like radians per second, and finally we are getting radians per meter as a unit for propagation constant. Next, wavelength. The formula for wavelength is this one, C by nu. C is equal to nu lambda. That's very well. So lambda is equal to C by nu means C value தெரியுமோ 3 into 10 power 8 constant value divided by nu value already they have given 50 into 10 power 6 hertz. Okay, so when it is 50 into 10 power 6, here it is like 5 into 10 power 7 and it is 10 power 8. So 3 by 5 into 10 power, it is what? 10 power 5, no? Sorry, it is 10 power 7, no? So 3 by 5 into 10. Am I right? 3 by 5 into 10. So 3 by 5 means 0.6, no? 0.6 into 10 means you will get 6 meters, no? Right. So it's a mathematical process. It's simple. What is the formula and what are the quantities? Whether the quantities given or we found, that is the matter. That is the matter from physics point of view, right? So it's a mathematical process. It will give us wavelength as 6 meters. Wavelength as 6 meters. Okay, right. Next, B. Observe carefully. What is B? Find expressions for magnetic field and electric field. Find expressions for magnetic field and electric field. Okay, right. So what is the electromagnetic wave? Electromagnetic wave is nothing but electromagnetic wave consists of oscillating electric field and magnetic field perpendicular to each other and also perpendicular to the direction of propagation of wave. Direction of propagation of wave, right? That's why whenever you are going to see here, all are mutually perpendicular. All are mutually perpendicular to each other. See here. See, now we are going to write the expressions for B and E, right? You know that this is what expression for E and it is the expression for B. And if you know these values, we have to substitute, right? So after substituting these values, you are getting the expression for electric field and magnetic field, right? But one thing is important. I didn't write here, but I am saying, please be concentrate. Here, suppose if the wave is propagating in the positive x direction. Suppose if the wave is propagating in the positive x direction, then the electric field vector will be in the positive y direction and the magnetic field vector will be in the positive z direction. This is because all three vectors are mutually perpendicular. This is because all three vectors are mutually perpendicular, right? So that's what from the definition of electromagnetic wave. It is not a new thing, but he took the specific directions. For example, what is the positive x direction, what is the positive y direction, and what is the positive z direction. Suppose if the wave is propagating in the positive x direction, wave is propagating in the positive x direction, then electric field vector in the positive y direction and the magnetic field vector will be in the positive direction. This is because all three vectors are mutually perpendicular to each other. Okay, right. Now, equation of electric field vector is given as E bar is equal to E naught into sine kx minus omega t into j cap. Just now I told you, just now what I told, electric field vector is along the positive y direction. Positive y means I can put j cap no to represent symbolically, to represent the vector form, just I can put j cap no. J cap is the unit vector along positive y direction or positive y axis. Similarly, k cap is the unit vector along positive z axis. I cap is the unit vector along positive x axis. So finally, I cap, j cap, k cap are the unit vectors along positive x axis, positive y axis and positive z axis. Okay, right. Now, see, this is the expression we have, and we have to substitute. See, what is E naught given? That is what 120 Newton per Coulomb into sine k value is evla. So 1.05. X is right, x minus 3.14 is just like is indicating like x no, x or y. See, that's I already told you, the wave is moving along the positive x direction. It is very important to remember. 1.05 into x minus, it is what, 3.14 into 10 to the power of 8 into, see, it is what, 3.14 into 10 to the power of 8 into t into j cap. And for magnetic field, B bar is equal to B naught into sine kx minus omega t, sine kx minus omega t into k cap, that is equal to 4 into 10 to the power of minus 7, and remaining values same, that is what, sine 1.05x minus 3.14 into 10 power 8 into t into k cap. Okay, right. So in this 8th problem, they have given electric field amplitude of electric field, that is what, 120 Newton per Coulomb, and given frequency nu as 50 megahertz, but asking to find B naught, omega, k and lambda, and after that he is asking to write the expression, he is asking to find the expressions for B and E. Right, first we have written the given things, E naught and frequency. Next, A1, magnitude of magnetic field strength is given by B naught is equal to E naught by C. Right, the mathematical process is giving for us 400 nano Tesla. Then omega is equal to 2 pi nu, that is equal to 2 pi into 50 into 10 power 6, which will give us 3.14 into 10 power 8 radians per second. Then we calculated k value as 1.05 radian per meter, and then we calculated lambda value, which is 6 meters, 3 into 10 power 8 into 50 into 10 power 6 into 6 meters. Okay, right. Next, B. In this problem 8, B is romba mukyama, romba important, because it is need point of view also. Sometimes by giving the quantities, he is asking to write the expression for magnetic field vector or electric field vector. That is what asking to write the expression for amplitude of electric field and amplitude of magnetic field. That's why this model is very important. I mean, writing of expressions for magnetic field and as well as electric field. Right. So here, regarding this problem, I want to explain. Regarding this problem, suppose if the electromagnetic wave is moving along positive x direction, then the electric field vector is moving along positive y direction, and the magnetic field vector is moving along positive z direction. That's why here they have, he kept j cap, that is what here he kept k cap. Okay, right. Now E naught into sine kx minus omega t into j cap, that is equal to 120 sine. We have to write this values, omega k value and omega value. Then for magnetic field, this is the expression, and we have to substitute. It is what, 4 into 10 power minus 7 no. that is into sine into 1.05x minus 3.14 into 10 to the power of 80 into k cap. Okay, right. So in this class we discussed 4 exercise problems from exercise 5 to exercise 8, 5, 6, 7, 8. Okay, right. In our next class we will continue with next continuation problem, that is exercise 9. Thank you.